The underlying technology for AI agents is mature. The economics of deployment pencil out. Yet, large-scale corporate AI initiatives consistently fail. Attempting to inject high-variance AI directly into legacy workflows is equivalent to climbing into a roaring jet engine to repair it while the plane is mid-flight. The physical location of the deployment determines the outcome. Even with mature technology, the wrong environment triggers a terminal response from the organization. The operational core of a mature enterprise is mathematically optimized for a specific set of outcomes: margin defense, process predictability, and strict risk mitigation. Because of this optimization, the core functions as an institutional immune system. It identifies the disruptive, high-variance behavior of early AI agents as a threat to ongoing operations and systematically starves or blocks them. Attempting to force a transformation from inside the mothership fails because the host organism is structurally designed to kill the intervention. The classic innovator's dilemma assumes that disruption arrives from external competitors offering cheaper products. In the AI era, the threat originates from the edge of the organization itself. The successful strategy abandons the attempt to rewrite the legacy core. Instead, you build a parallel system designed to outcompete it. This parallel structure is known as the edge twin. An edge twin is a board-mandated, CEO-sponsored business unit. It uses an AI-native architecture to rebuild and replicate specific workflows from the mothership, executing the exact same economic purpose. This structural separation provides a required physical boundary. It shields the young AI initiative from legacy middle management, keeping it alive long enough to prove its return on investment. Deploying agents requires understanding the Peter principle for AI. Organizations will continue to delegate tasks to an AI system until it eventually exceeds its competence and fails. You cannot predict this exact failure point through theoretical modeling. An AI system learns its boundaries through the recovery loop following a lived operational failure. This graph tracks the autonomy ceiling. Agent capability climbs until hitting a failure threshold, triggering recovery. If this loop occurs inside legacy operations, the blast radius impacts real customers. If inside an isolated edge container, the failure is quarantined. If an organization exceeds 500 employees, coordination layers have formed and the immune system has mass. At that scale, the core cannot safely absorb these live experiments. The edge twin operates strictly as a containment zone. The mothership inherits the automated workflows only after boundaries are established by safe, localized failure. Because the autonomy ceiling is discoverable only by exceeding it, running that initial experiment on legacy customers presents a catastrophic risk to the business. A newly spawned edge twin requires very little initial mass. It consists of a highly insulated team of 3 to 5 human operators managing a dense cluster of AI agents. This diagram illustrates the architectural boundary. The edge venture bypasses the legacy hierarchy, reporting directly to the CEO. Inside the venture, the drive anchor operates at machine tempo. This is the full intelligence stack, insulated from the mothership's coordination layers. To balance velocity, the shape anchor establishes the governance control plane, enforcing parallel run discipline and direct CEO budgeting to prevent defunding. In March 2026, the financial technology firm Block executed a live experiment in this architecture, reorganizing to flatten their entire corporate hierarchy into an intelligence-driven model. Dissolving middle management provided early validation for Sam Altman's projection that organizations will soon operate as scaled digital world models, or mini AGIs. However, Block's aggressive rollout highlighted a critical flaw. They deployed a high-velocity drivetrain, but omitted the formalized shape governance controls. Operating in regulated financial systems without formal ledger mapping or runtime kill switches generates severe compliance vulnerabilities. The system is exposed to unchecked runtime drift. Without a meticulously engineered governance structure, the extreme velocity of an AI-native drivetrain results in catastrophic operational drift. Enterprise CIOs often assume this parallel structure requires a risky, massive fork of the enterprise data estate. It does not. The edge twin and legacy ERP connect through a strictly governed unidirectional API pipeline, enforced by workflow scoping and correlation IDs. This pipeline enforces strict boundaries. An agent handling order exceptions can pull shipping and inventory data, but is blocked from querying the HR system. Security protocols require all credentials to be short-lived and revocable, with every single call logged to prevent unauthorized crawling. A rigid prime directive governs conflict resolution. If the edge twin and legacy ERP disagree, the ERP always wins. The edge twin functions purely as a reasoning and orchestration layer. It earns its data access task by task, keeping the legacy systems insulated as the absolute source of truth. Migrating tasks require strict sequencing. You move the easiest workflows first, waiting to prove those before migrating high-judgment tasks. Contact centers provide a historical precedent for this migration. They evolved from human labor to AI-native resolution layers, collapsing individual transaction costs by a factor of 10 to 100. Bank of America ran this parallel process successfully. They deployed Erica as a separate edge twin alongside retail operations, absorbing over 1 billion interactions without disrupting core services. Executives must understand the underlying portfolio math of this strategy. A 70 to 80% failure rate for individual edge twins is mathematically expected. 50 years of venture capital data confirms this pattern. High attrition rates are the structural signature of every major technology transition. Successful organizations run this portfolio with discipline. They rapidly terminate failing twins, harvest the knowledge, and ruthlessly reallocate capital to the survivors. The greatest threat to edge deployment is not a failed twin. The danger lies in an executive misreading that failure as a flaw in the strategy, rather than a required data point for the overall portfolio. For the C-suite, the tactical stirring point is straightforward. Spawn your first edge twin in the business unit that carries the highest ratio of coordination work to actual judgment work. This sequence, detect, spawn, migrate, deprecate, and repeat, drives the transition. The process establishes a continuous migration engine, shifting the enterprise into an AI-native operational state, one workflow at a time. You never attempt an existential transition of the core while that same legacy mothership is actively funding the survival of the company. The edge twin isolates the chaotic, necessary failures of AI at the periphery, ensuring the core operations center inherits only proven, stable competence. Do not transform the core. Build an AI-native parallel system, map it safely to your ledgers, and execute a steady campaign to outcompete your legacy.